Hello, welcome to this episode where we shall be looking at the prediction for the mathematics paper 1 for the grade 11 gene examination. Okay, so within this paper 1, there's usually 2 to 3 topics that we normally focus on for the June exams, okay? Depending on the province and basically the coverage. So question number 1. Okay, before we even talk about the question numbers and what exactly is featured within the questions, we focus on a paper that is more than 50 marks, okay? That is number 1. So above 50, meaning that the target could be 75 or even 100 marks. Now you find some generous examiners that will even give you 150, just like the grade 12s, okay? So regardless of the condition that you find yourself into, the topics that are going to be tested will be literally more or less the same. Okay, so the first topic that we normally focus on is the algebra. Okay, under this algebra, we can break this down into what we call the quadratic patterns or the quadratic equations. Okay, using what we call the quadratic formula, as well as the factor method to do the factorization and solve the equations, okay? 2, we can also have what we call the simultaneous equation. Simultaneous equations, because they love this also. And then 3, still under algebra, we can have what we call the nature of roots. Then 2, we have what we call the exponents. People call them indices, okay? Exponents and indices, that's the plural of index. Under this, even surds could be asked within here, okay? Then what else do we have? Number 3 is what we call the functions, okay? Functions, sometimes we call them graphs. So we have the different types. We have the parabola and the straight line parabola. We have exponential, okay? We said straight line. And then what else? These are 3, and then the favorite one, the most loved, which is the hyperbola. Okay, now the 4th topic is optional, okay, depending on the province, which is like the number patterns. Now, why am I saying it's optional? Now, some provinces on their teaching plans have this topic for term 4, okay? And then some provinces would opt to have it in term 1. So the paper I'm gonna use, yes, I'm gonna have them so that I cater for those people that have already done the number patterns. Okay, but I know for sure that most provinces are supposed to do these number patterns in term number 4, meaning that it's only the algebra, the equations, and all of those things, exponents and the functions, that should constitute our paper 1. So I'm going to use this paper with the questions that are set, just to show ourselves, like to give ourselves a guideline of number 1, how a paper 1 looks like, how is it structured, and how do we approach the questions, okay? Now, if it's your first time on this channel, please feel free to subscribe and follow all other social platforms of Danley Duke, and feel free to even like, comment, so that if there's any sort of new content, you would be among the first people to be notified so that you don't miss out. Okay, so instructions are telling us that we have 6 questions. We need to answer all the questions, okay? Follow follow the instructions for each question. You must show calculations. Answers only, cannot be given full marks. Use a calculator that is approved, and if necessary, we must round off only if it is necessary, unless they tell us otherwise. No? Diagrams are not to scale, so we're not going to be using a guesswork system. And then lastly, We need to write neatly. I'll also try to write neatly, okay? Okay, then question number 1. Determine the value or values of x for which the expression, now this is the expression, okay, for which the expression has real values. Now, one thing we know is that for an expression to have real values, we must just end up with a positive answer within this root sign. For as long as the answer is positive, what happens next? We don't care. It will be real values. Now, we don't have any options or any solutions that we can pick from, but rather we can think of anything, okay? Number 1, if we use a 9, this whole thing is going to be undefined. And my focus is now by the denominator. If we use a number that is greater than 9, okay, we're going to have a negative within the denominator, which will lead to a negative within the entire thing. Meaning that our x can only be a negative number that is smaller or equal to -9. So I'm going to say that, no, not -9. Why must I say -9? We said smaller or equal to 9, but it doesn't have to be equal since it's gonna cause issues of being undefined and stuff. So let's just focus on the less than 9. So I'm gonna say x must be less than 9. Well, if it's an 8, we shall get a real number. So I believe that is much more better and well presented. Okay. Then for something to be undefined, remember we say that the denominator needs to be a 0. So for me to get this to be a 0, x needs to be a 9. All right. Then if we're given that x is a 1, is this expression rational or irrational? You must validate your answer with appropriate calculations. Okay, so if x is 1, let's try to do the substitutions and see. So that's going to be 1 squared plus 4 over 9 minus 1. This is under square root. So it's going to be 5 over 4. So we cannot find the square root of 5, but we can find the square root of 1. So which means it's going to be root 5 over 2. So since it's a root 5, just the root 5 alone is an irrational number. So we're going to say this is irrational. Do we need reasons? I doubt whether we need any reasons. What's going on here? What is going on here? Why am I having a 4 there? There is no 4, man. It's supposed to be 8. Baba, what's going on? Okay, so it's 5 over 8. And then that is irrational. So that's all we have to do for that case, okay? Then 1.1.4, determine a value, just one, of x, where the expression will yield a recurring decimal. Think of a number, okay, where the decimal is going to be recurring. How about if we think of 0 to be our number? Just say, what if it's a 0? Because that's going to be 4 over 9. Square root of that is going to be 2 over 3, which is recurring. So x is a 0. Yeah, makes sense. Okay, then 1.2. If you're given 2x squared minus 3x minus k is equal to 0, they want us to get the value of x if k is a 5. So let's use the factor method. Let's do. So 2x squared minus 3x minus 5 is a 0. Let's factor this out. Or you can use your quadratic formula, please, so that you end up with the same answers, okay? For me to get a 5, I will have a 5 here, and then I'll have a 1. Then minus and plus, I don't know if that makes sense. If that makes sense, yes, I think it does. So meaning that x can be a 5/2 or x can be a -1. And so if that is true, then those will be our answers. 2 marks for that. Then if x is a 4, we must give the answer 2 decimal places. So we must use the quadratic formula. So 2x squared minus 3x. They said if x is a 4, so which means minus 4 is equal to 0. So our a is a 2, b is -3, c is -4. And we know that from our quadratic formula, x must be -b plus minus the square root of b squared minus 4ac, everything is over 2a. So if we try to do the substitution here, it's going to be negative with a -3 plus minus square root of -3 squared minus 4. The a is a 2, this is a -4 over 2 times 2. So just as plain as this looks like, okay? And then all we have to do is punch this into our calculator. Please do not, okay, do not break this down to say 3 plus minus. I mean, if you have the time and you're done, please go ahead. But if you're not, just punch this, because at some point we expect you to know how to use, okay, a calculator. So we're gonna have that plus that over that. So my first x is giving me a 2,35. Okay, if I do the reverse with a minus, I'm getting -0,85. So in this question, we are very, 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 very not generous, okay? Whereby if the rounding is wrong, we shall penalize you, okay? So just the steps, 1, 2, 3 steps, and then you have the answer. You get your 4 marks. No, actually there are 3. Okay, so then 1.3.1. We have x minus 4 is equal to negative root of x minus 2. Okay, 1.3. We have x minus 4, it's got negative x minus 2. Is that correct? Yes, it's correct. Okay. So step number 1 of solving this, remember the root sign needs to be isolated, which is already done for us here. Okay, don't worry about the negative sign. Then we need to get rid of the root sign by squaring either sides so that the root sign falls off. So that is squared, and then this also squared. Root sign goes. Opening this, we shall have x squared minus 8x plus 16 is equivalent to x minus 2. Then let's get the standard equation, moving everything to one side. How I got this is FOIL, x minus 4 and then x minus 4. Okay, so that's going to be x squared. When this one moves, it's a minus, so it's going to be minus 9x. This one moves, it's going to be a plus, which is 18. So the two numbers I look at that will give me 18 and the -9 must be 6 and 3 negative. So it's going to be x minus 6, x minus 3 is equal to 0. You solve this, x is going to be 6 or x is going to be a 3. Having obtained that, we need to test our answers, okay? Whenever we have a sad equation, there needs to be testing of the answers. So let's see, if we use 6, the original equation was something like this. So 6 minus 4 is going to be a 2. Negative, on the right-hand side, I have square root of 6 minus 2, which is a 4. Square root of 4 is a 2. And then we have a -2, this is a +2. So this 6 is out. Okay, I'll just cross it out like that. Or you can say no solution or not a solution. Then if I try 3, 3 minus 4 is going to be -1. Then 3 minus 2 is a 1. Square root of 1 is 1 with a negative. So which means this is the only solution that we need for this particular question. So we do that, we shall get all the 5 marks. Okay, as per the allocation. Okay, then 1.3.2, when we talk about the inequalities, create the standard equation. That should be your first step, since this is a quadratic inequality. So I'll have x squared minus 3x. When this one moves that side, it's going to be a +2. It's greater than 0. Okay, let's factor this out. X minus 2, x minus 1 must be greater than 0. Then I can get my critical values to be 2 and -1. Okay, but then how do I represent the solutions? The A is greater than 0. Okay, A is positive, and then the inequality is also greater. Meaning that if we have, let's say, that sort of scenario, we're focusing on regions like this. So we're focusing, if that's a -1, that's a 2. So x must be greater than 2, or x must be less than -1. This is option number 1. Other option is for you to use the parabola, do your shading off nice, call that a -1, call that a 2, you shade that off nicely. Okay. Yeah, I think that is all. Number 1.4, they want us to solve this simultaneously. I'll jot it aside. So 2x is equal to y plus 2. Okay. 2x is equal to y plus 4. No, they said plus 2. Yeah. Y plus 2. And then 2x squared is equal to 2 minus y squared. Okay. Now, first things first, whenever you're solving a simultaneous equation, okay, you need to identify which one is linear and then which one is quadratic. So equation number 1, this is equation number 2. Please label them, okay, to make life easy for yourself. Some people prefer using letters, equation A, equation B, no stress, okay, for as long as there's some bit of identification there. So the first one is a linear equation, which I can use to make something the subject. And y is already open, so I'll take the 2 that side, meaning that y is going to be 2x minus 2. Call this equation 3. Okay, that is equation 3. Then I'll have to substitute equation 3 into equation number 2. Now you need to be very, very, very careful. I know some learners, yes, they can make something the subject, but then when it comes to doing the substitution and opening up, wow, then that's where things are getting messed up. Okay, so 2x squared is equal to 2 minus, our y is going to be 2x minus 2, but everything is squared. So 2x squared is equal to 2. Let's open this up with the double bracket, and then 2x minus 2. So opening this up, I'm going to have 4x squared minus 8x plus 4. And then I'll open that bracket further and create a standard equation. So 2x squared is equal to 2 minus 4x squared plus 8x minus 4. Let me move this to that side. Actually, let me move everything to that side. So it's going to be a positive 6x squared minus 8x. This and this is going to be -2 when I move it that side, which is a +2. Is equal to 0. Okay. Divide through by 2. So 3x squared minus 4x plus 1 is a 0. Let's try to factorize this and see. That's 3x and x. This is 1 and 1. Because when I multiply 1 and 1, I get 1. 3x and x, 3x squared. Let's use negatives. Meaning that x is going to be 1 over 3, or x is going to be a 1. Then I have to use my equation number 3, okay? The one that I made, so that I can obtain the answers. for y. So our y was 2x minus 2. Okay, remember it is 2x minus 2. So if x is a 1, which means y is going to be 0. Then if x is a third, which means it's going to be 2/3 minus 2, which is going to be 2 minus 6 over 3, which is negative 4 over 3. Okay, so that is basically how that question would have been approached. So there's always a lot of marks in simultaneous equations. So if you keep yourself calm and composed and make sure that you follow through step by step, we shouldn't leave these marks, okay? They are worth every mark count. 6, imagine. 1.5, for which values of p will this thing have equal? No, we'll have 2 unequal roots. Not this thing, this expression or equation. Okay, for which values of p? So if we have negative 2x squared, let's take the p that side also. Negative 2x squared plus 4x minus 3 plus p is equal to 0. Okay, so first things first, whenever they talk about nature of roots and you're given an equation, just push everything to one side so that you have a 0 on the other side. So I know that this negative 2 is going to represent my a. This 4 is representing my b, and then the whole of that is going to represent my c. Now the question is, what condition of the discriminant or the determinant must we have in order for us to have unequal roots? Okay, so that's going to be the question. So the condition is that the discriminant needs to be greater than 0. So we know that nature of roots, this discriminant is the same as b squared minus 4ac. It must be greater than 0 for us to have unequal roots. But we say that our b is a 4. So that's going to be like 4 squared minus 4. What's our a? Our a is a negative 2. What is our c? C is negative 3 plus p. Must be greater than 0. Then we open this up. So that's 16 minus. Let's have this not that. Let's have it as 8 minus 3 plus p is greater than 0. It's gonna make sense. Do I need to open it up all? Just look for shortcuts. Look for shortcut, Baba. So I'll have 8 into negative 3 plus p is greater than negative 16. Let's divide through by 8 so that we don't waste a lot of time. So negative 3 plus p is greater than negative 2. Then I'll move the 3 that side. P is greater than negative 2 plus 3, meaning that p must be greater than 1. Okay, so that is what I'm ending up with. Okay, alternatively, somebody can open it up and, you're going to get the same thing. So for as long as p is greater than 1, then the answers we're going to get are going to be unequal. And then for which values will it have both positive what? Positive roots. So for us to have the positive roots, okay, we know that the a must be greater than 0 and the b must be less than 0. A should be greater than 0 and then the b should be less than 0. But already we know that our a here is a negative. So how do we change it to positive? The b here is a positive. How do we change it to a negative? So what we're going to do, okay, what are we going to do? Instead of us having a p minus 3 or a negative 3 plus p, let's have it the other way around and say that we're going to end up with, this is 1.5.2. So it's saying a must be greater than 0, b must be less than 0. So we're gonna have 3 minus p should be greater than 0. Now our focus is on the c. Okay? So we need to change the c around and then see what's gonna happen. Then if I move the 3 to that side, negative p is greater than negative 3, divide both sides by negative 1, meaning that p must be less than 3. So what we're going to do is, since our c is above 0, 1 should be less than p and then less than 3. So it's going to be the condition for p. P must be between 1 and 3. 1 and 3. Okay, so that is how we would have gone about with 1.5. Then 1.6, can we show that this equation has no real roots for p and q, being elements of real numbers, and q is never a 0? Okay, let me put it aside. So we have p plus 1, okay? And then what we have there is p squared. That's x squared is equal to negative 2pqx. We are subtracting q squared. Wow. Okay, so how do we show that this thing has no real roots? How do we know that doesn't have any real roots? Okay, so let's open it up, okay, and express the whole thing in the general term of x squared bx plus c, so that we get to know what's our a, what's our b, what is our c, and then we shall draw a conclusion from that point. So we already have this as our x squared, so meaning that all of this is our a. So I'm going to have p squared plus 1 into x squared plus 2pq with x, and then plus q squared is equal to 0. Okay, so let's categorize this. Let's break it down. So this is our a, this is our b, the whole of this, and then this is our c. Now for the roots to be non-real, the discriminant must be less than 0. Okay, meaning that our b squared minus 4ac should be less than 0. If that is true, then we're good to go for sure that it has no. Okay, so our b squared, we have 2pq. 2pq. So 2pq, we square this. For what is our a, we have, let me start with the c. Let me start with the c. So 4q squared into p squared plus 1 should be less than 0. Now the question is, what are we solving? Okay, that's what somebody is going to ask me. What are you solving by looking for this? So my focus is mainly the q aspect. Okay, let's open this and see. This is going to be 4p squared q squared minus 4p squared q squared minus 4q squared is less than 0. So this and this dies out. So if that is dying out, I'm being told that the determinant, okay, is a negative 4q squared. This is what we are left with. For now, we are saying this must be less than 0. Negative 4q squared is less than 0. Now, I think this is just enough for us to draw the conclusion. Since it's a negative, okay, the whole thing is a negative, regardless of what q is, it's a negative, which is less than 0, which rhymes with a condition. Negative is less than 0. So the left-hand side is equal to the right-hand side. So therefore, we're saying that the roots are non-real. Alternatively, what somebody would have done is, since we're not solving for anything, we were just meant to kind of look for the discriminant alone and then bring out the 0 part since there's a negative there. All right, then we move on to question 2. Exponents, that's, and some equations. Okay, we have 2 to the negative 1 plus 3 to the negative 1, everything is squared, okay? So there's a law of exponents, whereby if we have a to the negative 2 is the same as 1 over a squared. So that's what we're gonna use for 2.1.1. So it's like 1 over 2 plus 1 over 3, everything is what? Squared. Use the butterfly method to solve this, or if you can get your LCD, LCM, perfect. So we're gonna have 3 plus 2 over 6, everything is squared, which is 5 over 6 squared, meaning that we have a 25 over a 36. Okay, so that is done. With 2.1.2, what needs to be done, because it's an exponential expression, we need to change these bases to a base of 2. Okay, you need to change it to a base of 2, meaning that it's going to be 2 multiplied by 2 squared, which is 2x plus 4, minus 2, which is going to be 2x minus 6. Everything is 2 to the 2x, because when you multiply numbers the same basis, you must add up the exponents. Let's factor out the 2 to the x, 2 to the 2x, because whenever you have a plus or minus, factorization is a must. So we're going to be left with 2 to the 4 multiplied by 2. 2 to the 4 is 16 times 2, which is a 32. Minus, I'm going to be left with 2 to the negative 6. We know that 2 to the 6 itself is 64. So 1 over 64 over 2 to the 2x. This cancels that. And then we just left with that fraction, which we can, oh, they told us not to use calculators. Okay. But one thing we know is that when we reach at this point, then everything seems kind of direct. Because if I'm to use the butterfly approach, then I'm just going to multiply the 64 and then 32 and then that and that. So what do I get? Is 2048 minus 1 over 64, which is 2047 over 64. So we can leave it at that. Remember, we're not supposed to use calculators, so yes. But if you know how to use a calculator, just at this point when you're doing your multiplication and what, yes, that's acceptable, okay? 2.1.3. We have 3 to the negative a half. Let me put it aside. 2.1.3. 3 to the negative a half, open brackets, root 12, okay, plus the cube root. Yes. Is this for real? The cube root of 3, I'm lost. Like, I'm lost. Is that cube root or is just a 3? Okay, this one, yes, I agree, it's a cube root, but this one is not. Because it's a 3. Okay, let's see how that works. So let's change this side, or let's simplify the root 12, okay? So we know that root 12 is going to be the same as 4 times 3, which is the same as 2 root 2. So I'll say 3 negative a half into 3, no, because it's 4 times 3. Okay, so it's 3 root 2. What are you writing? Square root of 4 is 2, which means it's 3 root 2. Perfect. Plus, and let me change this cube root and say 3 root of to the exponent of a third. But why didn't I change even that? Okay, no, it's fine. Let's see. So that's 3 to the negative a half into 3 multiplied by 2 to the exponent over half plus, okay, 3 multiplied by 3 to the exponent over half. Everything is to the exponent over third under the. Okay, so let's now do the multiplication here. It's going to be 3 to the negative half multiplied by 3. And then 2 to the half plus, this is going to be 3 to the third, and then 3 to the 1 over 2 times 1 over 3. Okay. Is that all? We also have to multiply 3 to the negative half there. Okay, because this must affect here and then must also affect that side. All right, so when I simplify this and that, because the bases are the same, then I'm going to have 3 to the half and then 2 to the half plus this. Okay, let me just add up everything there. So that's going to be a third plus, that's going to be a 60th minus a half. Okay. And then when we simplify this, what is a third and a 60th? That's 6, that's going to be 9 over 18, which is a half. 9 over 18, which is a half minus a half, which is 0. So 3 a half multiplied by 2 a half plus 3 to the 0, which is a 1. Okay, meaning that it's the same as the square root of 3 times 2 plus 1. Meaning that it is 1 plus the square root of 6. I don't know if that is what you people are getting. Does it even make sense? It doesn't, yeah? Okay, let me just restart it again. I don't know from which step. Unless if it's something that I did wrong. Unless if there's something that we did wrong. Where did we go wrong? Okay. Is it here when we're opening up? Let's see. I'll just reevaluate the whole thing because people are crying. Okay, let's see. Once again. Remember, it was 3 to the negative a half, root 12, the cube root of 3, root 3. Cube root of 3, root 3. Where's the cube root sign? It's over everything. Okay, perfect. Let me simplify what is inside there. 3 negative a half. 3 multiplied by 2.5. Plus, that's going to be 3, 1 over 3. And then 3 to the 1 over 6. Let's open it up and see if we're going to get the answer that people are looking for. When we simplify this, what is a third plus a 6th? We know that's going to give us a half. No? Is that true? Yes. So negative a half into 3 multiplied by 2 to the half. Wait, is it my problem? Yes, it's my problem. Yes, it's my problem. Because we say this is 2 root 3. Marantate. What's going on? So meaning this is a 3. And then this is a 2. Yes. Saying this is a 3. And then this is a 2. Okay, so let's see. We're saying this is a 3. Okay, 2 multiplied by 3.5 plus 3.5. I think this makes more sense. Take out the 3.5. So 3 negative 1/2 times 3.5 shall be having 2 plus 1. So 3 to the 0 and 3, which is 3. Yeah, makes much more sense. Thank you for that. Then 2.2, they want us to solve for x without a calculator. So what we need to do first, divide both sides by 2. So x to the 3/4 is equal to 8. Okay. Then we can write this as a base of 2. So that we have x to the 3/4 is equal to 2/3. Then for me to get x alone, I need to multiply this by 4/3, multiplied by 4/3. So that this gives me a 1. And then this cancels that. And then our answer just becomes a 16, meaning that x needs to be a 16. Then 2.2.2, we have 5 to the x. Okay, that's a plus. No, it's x plus 1. 5 to the x is equal to 150. Let's take out the 5 to the x. We shall have a 5 plus 1 is equal to 150. So 5 to the x times 6 is 150. Divide both sides by 6. Okay, so what's 150 divided by 6? That's a 25. Is it? Should be. Then 5 to the x is equal to 5 squared, then which means x is a 2. All right. Then 2.3, still without a calculator. Can we show that this is equal to that? So this takes us back to rationalization. Okay, so we have 9 minus root 54 over, say it's 2.3, 6 root 2. So step number one is break down this 54. So we know that 54 can be written as 9 times 6 now. What is the answer looking like? 3 root 2 minus 2 root 3. 3 root 2 minus 3 is 2 minus that over 4. 2 root 3, okay, something like that. Okay, so we're saying we can change this root 54. And if we change that, you can just punch it into your calculator as much as the question said without a calculator, but just punch root 54 alone. Okay, that gives you 3 root 6. So it's gonna be 9 minus 3 root 6 over 6 root 2. Now for us to rationalize this, just multiply by root 2, multiply by root 2, meaning that we're gonna have 9 root 2 minus this, and that's gonna be 3 root of 6 over, that's gonna be 12. Then okay, so this cannot be a root 6, but rather a root 12, okay? Because it's root 6 and root 6. Okay, then from there, what I can notice is that, yes, there's a 3. We can take out a 3. But this root 12 can also be written as a 2 root 3. That's going to be 4 times 3, okay? So if it's a 4 root 3, no, it's a 2 root 3, I can bring it here so that I have 6 root 3. So 9 root 2 minus, okay, what was the answer here? Root 2 and root 3, perfect. Okay, minus, we said 2 and 3 is going to be 6 root 3 over 12. So let's take out the 3, which is common. Okay, so we're going to have a 3 root 2 minus 2 root 3 over 12. So by 3 is 1, by 3 is 4. So that becomes the answer that the question was asking for. All right, then question number 3. Okay, question number 3 is number patterns. Like I said, for those people that did number patterns in term 1, they want us to write down the 4th term of the pattern. So from 4 to negative 3, which means we are subtracting 7. Subtracting 7. So the 4th term is going to be negative 17. Then they want us to get the general term. So it's going to be negative 7 with n. 4 minus 7 is going to be plus 11. Okay. Then calculate the number of terms within the pattern. So for us to get the number of terms, where there is Tn, let's put negative 277 is equal to negative 7n plus 11. Let's move the 11 to this side, which is going to be negative 288 divided by negative 7 should give us n. Is that going to make sense? Is that going to make sense? Okay, let me just punch that in the calculator and see if it's going to give me anything of this sort. Oh, this is 227, not 277. Ish. 227. Thank you. Okay, so when we subtract 11, that's going to be 238. Okay, so when you divide by negative 7, meaning that your n is going to be just a 3 and 4. So 34 becomes the answer. Then 3.4. The given number pattern above is the first difference of a quadratic pattern. This format. Determine if the quadratic pattern will have a maximum or a minimum. We must validate our answer. Now, since this is the first difference, and we know that 2a must be equal to negative 7, so a is going to be negative 7 over 2. Will it have a maximum or a minimum? So we're going to say it's going to have a maximum. Reason, 2a is negative 7, a is going to be negative 7 over 2. All right, then question 4, given the quadratic. So we have 69, 0. Let's see, 69, 0. And then we have negative 63. So that's going to be negative 69. This is going to be a negative 63, meaning that this is a positive 6. Yeah, it's a positive 6. What do they want? They want us to write the value of the next term. Next term. So if I plus 6 here, it's going to be 50 what? Is it 57? And that's going to be negative 120. I don't know, guys, help me. This addition is too much. Okay, so negative 120, that's what I'm getting, guys. Then the nth term, so with the nth term, this is gonna be 2a is equal to that. 3a plus b is that. A plus b plus c must be that. Then we do the application to A6, meaning that A is a 3. Then 3a plus b is negative 69. Let's replace a with a 3. That's gonna be a 9. So b is gonna be negative 69 minus 9, which is negative 78. And then we need to get a c, meaning that a plus b plus c must give us a 69. So 3 plus negative 78 plus c is a 69. That's negative 75. So 69 plus 75, which is 144, I guess so. I do the addition. Meaning that Tn is gonna be 3n squared, 78n plus 144. Then determine the smallest value within this pattern. Determine the smallest value. Now, for us to get the smallest value, when they ask you for the maximum value or the minimum value, that's more like asking you for the turning point. And for us to get the turning point, remember with x is negative b over 2a, this is a parabola, okay? Meaning that, let's get the position first. Meaning that we're gonna be having n is equal to negative b over 2a. Our b is negative 78 over 2 times 3. So what is 78 over 6? So 78 over 6 gives us 13. So position number 13 is going to give us the smallest number of this pattern. So 3 times 13 squared minus 78 times 13 plus 144. Punching that into the calculator, getting negative 3,603. No, it's negative 363. So that becomes the smallest value. So remember, this is hyperbola. In this sort of, no, it's not that way. It's just something like that, since the a is positive. All right, so that is with question number 4, which is number patterns. Now, question number 5, which is the functions. Now, with the functions, remember, we have different graphs. The first one they're giving us is a parabola and a straight line, okay? F of x is this, g of x is that. X-intercepts for f at a and c, graphs f and g intersect at a and b respectively. Point P is the turning point. Yeah. They want the equation of G. What do we know about G? We know point B, we know point A. And since G is a straight line, meaning that we need the gradient only, we already have the y-intercept as 8. So gradient is change in y over change in x, x2 minus x1. So I'm going to have 8 minus 0 over 0 minus minus 4, which is 8 over 4, which is a 2. So g of x is going to be 2x plus 8. Okay, it's a 2x plus 8. Then 5.2, they want us to get the values of a, b, and c in the form of x squared and that and that. What do we know? We have the intercepts. So we can use the intercept approach. A into x minus x1, x minus x2, something like that is equal to y. Meaning that tau y is a into x, we can say minus minus 4, which is a plus 4, into x, that's going to be minus 2. Okay, then let's use this point. When x is 0 and y is 8. 8a, that's a 0, we have 4. That's a 0, we have negative 2, which means our a is negative 1. If that is correct, then we open it up. Negative 1 to x minus, that's x plus 4 x minus 2. Okay, so we're gonna have a negative 1 into x squared plus 2x minus 8. Negative x squared minus 2x plus 8. So this is the equation that the question is typically looking for. But then what does the question need? The question just needed the values of A, B, and C. So our A is negative 1, our B is negative 2, then our C is 8. Then can we show that P is having negative 1 and 9? Remember, P is the turning point. Okay, so for us to get the turning point, remember x must be negative B over 2A. Our B, we said it's a negative 2. Okay, so it's negative 2 with a negative over 2. Our A is a negative 1. So that is 2 over negative 2, which gives us negative 1. Then we just need to substitute this, okay? And say what is f of negative 1? So it's negative 1 squared minus 2 into negative 1 plus 8. So this is going to be a negative 1 plus 10, which gives us a 9. Therefore, P becomes negative 1 and a 9. So you just need to show the steps and the calculations for us to arrive on how to arrive at that point. Then they want us to give the range. Remember, range represents the y values. Okay, range of f, which is the parabola. So if P is 1 and 9, sorry, negative 1 and 9, meaning that this graph is valid for all y values from 9 up to the bottom. So we're going to say simply that y should be less or equal to 9. If we have time, we could just say that negative infinity is less or equal to y, less or equal to 9, something like that, no problem. Then they want the equation of line P that is perpendicular to G, but passing through C. It's passing through C, but also perpendicular. So when lines are perpendicular, meaning that there's a 90, and what we know about that is that the product of the gradients must give us a negative 1. Meaning that the gradient of the perpendicular line multiplied by 2 should give us a negative 1. So gradient is negative 1/2. Then since we're using 2 and 0, from y minus y1 is equal to m into x minus x1. We're going to say y minus 0 is equal to negative 1/2 into x minus 2. Open this up. So it's negative 1/2 x plus 1. And that's what the question just needed there. Then the length of PQ, so where's PQ? This is it. The length of PQ. Now we know that F is on top or above, and then Q is below, or G is below, which means for us to get the length, we're gonna get the equation of F minus the equation of G, which is going to be like negative x squared minus 2x plus 8. We are subtracting 2x. Was it plus 8? Yeah. When you open that up, you're just gonna have negative x squared. The 2x and the 2x is gonna give us minus 4x. And then that will die out. So this is the length. Unless, we just need to be specific. X is what? Negative 1. So replace x with a negative 1. That's gonna give us a negative 1 plus 4, which is 3 units. Alternatively, what one would have done is replace this negative 1 here so that we have a 6. And then with the negative 1, we have a 9. So 9 minus 6, you have a 3. I think that was actually the easiest. Just putting a negative 1 here and then subtract. Okay, so lastly, 5.7, for which values of f of x over g of x is greater or equal to 0? F of x or g of x is greater or equal to 0. Now, if you look at the graphs themselves, remember we are dividing these graphs and we are ending up with a negative. Okay, it's more like you're multiplying and then you get to negative. So you can only arrive at a negative if one graph is below and then the other graph is above. Okay, so where's that section? You see this section of these two. This graph is above the x-axis, this graph is below the x-axis. Okay, one is positive, one is negative. So this is a positive, this is a negative. But then they're telling us it's greater or equal to 0, which means positive. So both of them need to be above or both of them need to be below. So what we're going to say is that if x is less or equal to 2, because both negatives will give us a positive. Both positives will give us a positive. So x must be less than 2. Okay, that is for sure. But x cannot be negative 4. X cannot be negative 4. So we say x should be less or equal to, x should never be negative 4. Okay, so that is how we go about. So if x is ever a negative 4, then the denominator might end up being undefined. Remember, we're dealing with a straight line. So it's going to give us a 0 somewhere there. So that's why we're putting up that condition. All right, then lastly, question number 6, we have a hyperbola, and then we also have an exponential graph. Then they want us to write down the equations of the asymptotes. Okay, asymptotes is basically this and then that. So number 1, x should be a negative 3, and then y must be a 1. So that is how we write that out. 6.2, determine the x and y intercepts of k. So for x-intercept, we know that y is a 0, and for y-intercept, x must be a 0. So let's just substitute x with a 0 here. You're going to have a negative 4 over 3 plus 1, which is negative 1 over 3. So 0, negative 1 over 3. And then if you replace a 0 here for y, then you're going to have a negative 1 into x plus 3 is equal to negative 4. Open this bracket. I'll solve for x. So negative x minus 3 is equal to negative 4. Negative x, let's move this from that side, negative 1, meaning that x is 1. So we have 1 and 0. All right, then they want us to write the equation of the asymptote of h, meaning that y is in negative 4, because this negative 4 represents the asymptote. Then they want us to sketch both x and y. So let me just put that down here. Okay. That is x, then that is y. And then I'm going to start with the asymptotes and say we have negative 3 and a 1. So negative 3 somewhere here. And then a positive 1 is somewhere here. Okay. Then what do we have? So it's a, so we also have a negative 4 as an asymptote for the hyperbola. All right, let me use this mustard. Saying negative 4 down here. Okay, so I'm going to start by plotting the hyperbola. Because with the hyperbola, we said the intercepts are 0 and negative a third. So 0 and negative a third is somewhere here. And then we have 1 and 0, which is somewhere here. And then let's just draw something like that. So the hyperbola shouldn't cut the blue lines because those are asymptotes. That's graph number 1. This graph number 2 does not have any points, so you just have to sketch it as a formality because we must have 2 arms. Then for the hyperbola, we're done. Let's look at the exponential, say 2 to the negative x minus 4. Okay. Do they need both of them? Yes, they do. So with this one, you just have to try out any 2, 3 points, okay? So if x is, so x cannot be 0, né? Does it make sense? Does it make sense? If x is a 0, what's gonna be our y? Let me just erase this noise. Let me punch that in the calculator and see what we're gonna get. We said 2 to the 0, but anything to the 0 must always be a 1. And then because that's gonna be like 1 over 2 to the x, which is a 1 minus 4, which must give us a negative 3. So negative 3 should be somewhere here. And then if I'm to solve this, okay, 2 to the negative x is equal to 2 squared, meaning that x is negative 2. Negative 2 is somewhere here. Okay, let's put it somewhere here. The negative. Okay, so we already know the direction our graph is taking. Yes, they might meet up somewhere. There's no problem with the meeting up. Okay, we don't care whether they meet or not. Okay, probably that should be for another question if we are asked. Okay, so meaning that our graph is gonna be something like this. This is h of x. And this was k. All right, then having drawn that, they're telling us that if p of x is 3 times h of x, so we are increasing it. Write down the equation of the asymptote of p. So if you're multiplying this entire thing by 3, what's going to happen to the asymptote? Is it going to increase? Is it going to stay the same or what? So basically, it's a multiplication. So which means y is going to be negative 12. Write down the equation of q, the reflection of h in the y-axis. We are reflecting in the y-axis, which means the coordinates on the x must change sign. So it should be a 2 to the x minus 4. Because the sign on the x, if it was negative, it must change to a positive. Okay. And then determine the x values for which h of x and q of x are equal. So h of x is equal to q of x if I simplify this. Okay, so if h is a reflection of, because it's just about swinging it around. So it will swing and it will also be in the same sort of direction. Now the question is asking us for which values of x are the two the same? X needs to be a 0. Because that's the point where both graphs are intersecting or they are meeting. Okay. So guys, that's how that would be done. So at least with these functions, if you just practice how to, number one, sketch the graphs. What we like most is the hyperbola. How do we sketch the hyperbola? How do we sketch the exponential? How do we sketch the parabola? Yes, it's fine if you are comfortable with using the table method and point to point, and as much as you're gonna really take a lot of time using that. It's all about the technique and getting to know the shape. How does a parabola look like? What are the properties of a hyperbola? And then the exponential. Just understand the terminologies of the asymptotes and their importance. So having said that, I think I'll stop there and then wish you guys all the best in your practice. And let's meet again when we're looking at the solutions of some of the papers that you guys would have written. Thank you very much. And